Hello, my name is John Vincent, and I'm here with Swoosh Technologies. Thanks for joining us for NX University in this session of What's New in NX CAM. We're going to be covering the latest two releases of the software, NX 2007 and NX 2206. So, as we take a look at our contents for this session, we're going to cover a number of different productivity enhancements, as well as some new operation types and features added to the software. So I think regardless of what types of machines and operations you do, we'll have a little bit of content for everybody during this session. So diving right in, the first topic we're going to discuss is the ability to change our icon size for manufacturing create dialogues. So all of the dialogues for creating tools, geometry, operations, methods can now be influenced by a customer default setting under utilities, customer default, and we can specify between a small, medium, and large setting. This is going to influence the icon size we see as we're creating or selecting the various types of operations, tools, geometry, etc., as well as the tooltip flyouts that you see while hovering over these icons. So you get a little bit more ability to adjust based on your personal needs. Perhaps you're working your workstations, whether you're on a laptop, small screens, or you have multiple screens, you can really have the interface suited to your specific needs. You'll see we have a new operation type, and really what this is, cam_legacy, is just a bucket. A bucket where we're placing some of our legacy operations. So in this case, the first two are legacy operations for threading and vertical threading, as well as our flow cut reference tool operation. So these particular operations have new replacements that we'll discuss here in a little bit. And then the last one is it's now called legacy 3D model chamfers. This is really just a floor wall operation. This operation was actually removed from the software in NX 2007, and there was some pushback. A number of customers say, hey, we really like this operation type. And even though it's redundant in the software, it's been brought back, and it's located under this CAM legacy operation group. So you have it at your disposal if you want to use it inside of your NX programs. The operation validity report is a great way that you can embed some quality into your programming practice. This is a way to go through and just make some high-level checks whether certain aspects have been inspected prior to releasing your programs. When you launch the validity report, you'll see that this is a dynamic menu that'll update based on your current selection. This can be selecting individual operations, program groups, nested program groups, doesn't really make a difference. The criteria that you're checking in the operation validity report is customizable, so you can check for things such as gouges, tool holder collisions against the part, tool holder collisions against the IPW. Does the tool have a path? Does the operation have speeds and feeds specified? A lot of great options here. And you'll get a roll-up summary for the individual operation, as well as the program group that the operations belong to, kind of giving you the lowest common denominator. You can essentially get three results here. One, that the check was passed. Two, that the check was failed. Or that the check was not performed. So this will allow the operators to make sure all the necessary checks are completed before sending out the program out to the shop floor. Now on to our first new operation type, which is flow milling. Flow milling is the replacement for our flow cut operations that you're likely familiar with. And flow milling solves a number of the issues that existed with flow cut. First of all, we'll be able to better understand or recognize uncut material by previous operations when using bowl mills. That was a limitation or pain point in the past. So we'll have a better understanding of that uncut material. We have better transitions between different cut levels, much more consistent results in terms of various cut areas, uncut material detection, shallow features, sharp corners, sometimes represented problems. So we're going to have a lot of improvement and consistency inside of the flow milling operations. You'll notice that we still have 3 operation types, just like flow cut, where we have our flow mill single pass, flow mill multi-pass, and flow mill reference tool. One of the main pain points was this setting instead of flow cut for fine corners. And this was influencing the behavior of what do we do when we have corners, corner geometry, where some of the surfaces belong to our cut area and some do not. Well, we had a setting to say go ahead and cut only the corners totally inside of the cut area or with our adjacent geometry adjacent to our cut area. But the results were very inconsistent inside of flow cut. This is all solved inside of flow milling, and now whatever settings you specify in the operation, you're going to get the accurate results across the board in these new flow mill operations. Next point is some of the small regions for uncut material. In flow cut, we oftentimes had kind of truncated tool paths or abbreviated that I've felt that there should be smoother step overs and that there's more material than the software thinks, and that's all been solved inside of the flow milling operations, so you'll get much more predictable results. Here on shallow features and small corners, we'll see the results in flow cut at times omitted geometry or truncated that geometry, whereas flow milling is going to honor those settings as, again, you would expect across the board. So, what if we have existing flow cut operations and we open them in the latest versions of the software? Well, we can go ahead and migrate these operations. So when you open a legacy part file with flow cut operations, we can manually choose to go ahead and migrate them to flow milling operations. Again, we'll have to go ahead and generate the tool paths after that change has been made. Additionally, if you just want to update all of your flow cut operations, you can set a customer default to automatically migrate as soon as you open up that part file that may contain any flow cut operations. Of course, you can still go in and verify that operations have been migrated by choosing the migration option, and it'll verify that, yes, the operation has already been migrated. Now, if you have flow cut operations that are not migrated, and you try to copy and paste them inside of the new releases, you'll get an error saying that the objects cannot be copied. This is by design, so we don't go ahead and copy and keep using the flow cut operations. If you have a need for that, there is a customer default. Go ahead and reach out to us, and we can help point that out to you. That'll allow that copying. So the flow milling operations have already proven that they're vastly improved over flow cut. One caveat I like to point out is that flow milling really works best with solid bodies. If you're trying to use a series of sheet bodies, things like that, there can be some mixed results. So try to keep working with solid bodies whenever possible. Area mill cut patterns. A number of releases ago, concentric and radial cut patterns were removed from the software. At the time, this is when guiding curves was getting a lot of enhancements, and the belief was that all the strategies that customers were using, these concentric and radial patterns, could be handled inside of, or could be handled with the guiding curves. Well, a lot of feedback was given to Siemens from the users that they really wanted these cut patterns back in, and this is a great example of Siemens really listening to the users, and they have been reinstated in NX2206. So now on to talking about thread turning and operations, the tools and the operations. The new operation type is going to be much more familiar to some of the other latest, greatest operations like hole making, hole milling type support. If you're familiar with the legacy threading operations, they were very, very manual. You had to specify crest lines, root lines, things like this inside of the operation. A lot of manual selections. Well, now when you use the new thread turn operation and the new tooling types, the default option for specifying our thread information is going to be model-based. So we're going to be using information from within the 3D model, in this case, the actual threaded feature. And of course, we'll inherit the type of thread, pitch, all the necessary information to support our toolpath of our threaded features. We also have the ability to influence our infeed method now. So there's 4 options. Radial infeed, kind of just an incremental, kind of standard approach. We have a rear flank infeed and front flank infeed, kind of specifying where do you really want this tool to be cutting, or the incremental infeed, which is kind of alternating method. So it alternates cutting with the infeed side of the insert and the rear flank of the insert. Just a way to balance wear a little bit differently. So that's a great approach, using the model-based input here and getting all the information directly from your 3D data. But what if we don't have that? There's plenty of scenarios where we're working with data, whether it's from our internal departments, our customers, and maybe this type of information is still portrayed only on a two-dimensional drawing. That's no problem with the new operations. We can use the input method of from table in that scenario. So we can simply specify a cylindrical surface of where a thread feature is going to reside. And in this case, maybe we're looking at a detailed thread. That's fine as well. But we simply specify what is our thread standard and our thread size, and the operation is going to do the rest in terms of generating the output for that operation. So much less, fewer inputs from the operator, from the programmer, less chance for error. There is also a manual approach if you have some oddball threads or things of that nature. You're not out on an island here. You can still do a manual programming approach. That brings us up to UAxis support. A UAxis turning option is something that's becoming more and more common on different mills. And oftentimes this will be in conjunction with an auxiliary facing head. And really what this is doing is essentially adding an additional axis to the machine. So in this case, we're programming turning operations, but instead of programming maybe on a traditional lathe, in your X and Z axes, we're programming still on multiple planes. And we're still programming kind of our Z, our feet or depth of the option with our milling head, but the actual diameter of our feature is being controlled by this U axis, kind of this auxiliary axis. So the big enhancement here is how our IPW is handled inside of NX with these multiple spindles, because we're creating different spindles for all the different orientations of our features. And by default, in previous versions of NX, anytime we had a turning spindle, we would always want to revolve our IPW. Makes sense. Typically in a lathe operation, your part is spinning. Well, here we're in a milling machine. The part is stationary. The tool is what's spinning. So that's kind of the difference here when we're using our facing heads, that our IPW remains stationary, but we're still going to be able to accurately depict all of our rest material in conjunction with milling operations, turning operations, and show our accurate material removal while we're doing any kind of verified toolpath animations, simulations, things of that nature. We're going to get an accurate depiction of the results of our operation. So some great new functionality there for any users that are utilizing or have the ability to utilize this type of functionality. Machine code reuse. So this is something new, kind of a new concept. And what this is really doing is saving the posted code to your individual operations. Now, there's a number of areas where this is a benefit. First of all, when you go and post-process your code, what NX is doing is saving that NC code to each individual operation. So as we go and post, just like you would in prior versions, the whole post-processor run is going to execute. And once that happens, we'll see in this new column called machine code in our ONT, we'll get green check marks across all the operations, and this is indicating that the NC code is now associated to those operations. So a couple of things that are interesting here. If we go and run a second post-processor run, we will get a different dialog because we're not actually going to run the post again. If we go to execute this post-processor run again, and all the code is generated, it's all up to date, we're just simply going to get an option to export our code. So again, we're just exporting the actual NC code for use on our machine tools. So, what are some of the other benefits here? Well, if we go ahead and edit any operations, we'll see that, of course, we want to track, is the machine code staying up to date? Is it still kind of linked to the operation? So we make a change, generate our toolpath, and we'll see the machine code link is now broken. So that code needs to be posted again. So here's another differentiator in behavior. If we try to post this whole program, we're going to get a message saying the machine code is out of date. Do you want to run the post and update the machine code? And in this case, it's only going to update the code for that specific operation and then export the output of the entirety of the program. So you're running less of the post processor, less constraints on CPU usage, things like that. Again, depending on what type of parts, programs, things like that, running a post processor can be quite time consuming. In my opinion, the bigger benefit is when you get into NC machine simulation. This is where we'll start seeing how we can really start saving time with this machine code reuse. If you're familiar with NC simulation, you'll know that the post processor is run interactively with the simulation. Meaning here we can really see this visually, that our code is being executed as we're going through the simulation. And so what that means is once we have our machine code generated and we start another simulation run, we don't have to actually run that post again. So in the past we were simulating, we were running the post so many times and sitting there waiting. Now the code is just ready for us to use. I know when I am programming parts, I go into simulation very often, add an operation, change an operation, and this way it's only going to really have to generate code when absolutely necessary. Additionally, under our toolpath report, in addition to seeing our cutter location positions, we can now see the specific NC code for those lines as well. So another tool to help understand what's going on, maybe troubleshoot any issues, things like that. And of course, if you need to remove the machine code, you can certainly do that at any point in time. So here I have a few other small topics. I'm going to jump into NX to kind of demonstrate these. So the first one, we have two AI topics. So the first one is AI operation creation. And what this is this new group on the Home tab inside of manufacturing called Predict Operations. NX is learning with your typical picks and clicks as you're going through what sequence of operation usage do you typically go through. So this is going to be a dynamic menu that changes as you work with the newer version of the software, and it kind of learns, maybe what is my next operation I want to use as I'm programming. This option is on by default. The next AI topic is AI Edit Assist. So I've turned this one on in my session to show you here today, but there's an early access feature under File Utilities, Early Access, and there's this early access feature enables the parameter prediction in the Object Edit dialog. So let me go ahead and edit an operation in this sample file. As I open up this operation dialog, we'll see that there's a prediction node up here, and this is, again, a very dynamic menu. I think it will house up to 10 different settings. And again, NX is kind of learning what settings do we typically change within this operation type. So whatever my most commonly used setting or most commonly changed setting, that's going to appear at the top of this list. So I have essentially one location where I can have all of my parameters that I typically use. So again, this is being learned on your individual PC. Again, if you turn this feature off, you won't have this node inside of your operations. A couple other little notes. On the Discovery Center tab, under Start Here, Manufacturing, there's been some additional content to this manufacturing day one. So just worthwhile hopping in here, seeing what exists in here, some different topics, industries, things like that. Again, take a look at it as time allows. And the last one I want to point out is, because I've received a number of questions, is this operation type cam test new. So Siemens is looking to have more input on future operation types and functionality, and this cam test new is a new program that they have that you can gain access in a production release of the software to some of the newer tools that are in development still. So companies that are using the latest release of the software in production and will provide feedback, you can gain access. You can get some additional keys to unlock these features in the software. And again, you have to provide feedback to Siemens as they're developing these tools. So this is kind of a step between the early validation program that some of you may participate in, and that's kind of the beta testing. You can get the next release of the software, but it's not intended for production usage. It's really for testing purposes. And that's the differentiator here. This CAM Test New and the CAM Trailblazers program is really for leveraging the newest functionality in production and working cohesively with Siemens to further develop the tool sets. So that's what that CAM Test New is if you have the latest version of NX2206 and you've seen these operations. All right, again, I appreciate your time for this session of what's new in NX CAM, NX 2007 and NX 2206. If you do have any other questions, feel free to reach out to me. Here you have my email address and LinkedIn information. Feel free to contact me by whichever method you choose. Again, take care, and I hope you enjoy the rest of the NXU content.